Welcome to the sun. From our vantage point on Earth, the sun may appear like an unchanging source of light and heat in the sky. But the sun is a dynamic star, constantly changing and sending energy out into space. The science of studying the sun and its influence throughout the solar system is called heliophysics. The sun is formed about 4.6 billion years ago in a giant spinning cloud of gas and dust called the solar nebula. As the nebula collapsed under its own gravity, it spun faster and flattened into a disk. Most of the nebula's material was pulled towards the center to form our sun. How far and how big the sun is? The sun is about 4.5 billion years old. Type of star is yellow dwarf star, a hot glowing ball of hydrogen and helium at the center of our solar system. It's about 93 million or 150 million kilometers from our Earth, and it's our solar system, the only star. Without the sun's energy, life as we know it could not exist in our home planet. The sun is the largest object in our solar system. Its diameter is about 865,000 miles or 1.4 million kilometers. Its gravity holds the solar system together, keeping everything from the biggest planet to the smallest bits of debris in orbit around it. Even though the sun is the center of our solar system and essential to our survival, it is only an average star in terms of its size. Stars up to 100 times larger have been found, and one of it is Betelgeuse, a red giant. It's about 700 times bigger than the sun, and about 14,000 times brighter. Our sun is a medium-sized star with a radius of about 435,000 miles or 700,000 kilometers. Many stars are much larger, but the sun is far more massive than our home planet. It could take more than 330,000 Earth to match the mass of the sun, and it could take 1.3 million Earth to fill the sun's volume. In the outer layer of the sun, we have photosphere, chromosphere, and the corona. Let's start with the first outer layer, which is the photosphere. This is the sun's lowest layer and the layer visible directly from the Earth. It is also called the solar surface. Much of this layer is covered by granulation caused by the bubbling gas in the convection layer and sunspot caused by the strong magnetic fields. The sun's granulation look grainy in the photosphere, which result in the appearance of bright cell with dark edges. The photosphere temperature varies from roughly 6,500 degrees Kelvin at the bottom to 4,000 degrees Kelvin at the top. Next to the photosphere is the chromosphere, lowest layer of the sun's atmosphere and several thousand kilometers thick, located above the bright photosphere and below to the extremely tenuous corona. The chromosphere, named by the English astronomer Sir Joseph Norman Lockyer in 1868, appears briefly as the bright crescent red with hydrogen light during solar eclipse, when the body of the sun is almost obscured by the moon. This is the layer of the sun between 250 miles and 1,300 miles above the photosphere. The chromosphere has a temperature around 4,000 degrees Kelvin at the base and 8,000 degrees Kelvin at the top. As a result, in this layer and the other higher layer of the sun, the temperature increases farther away from the sun, unlikely in lower layer where it gets hotter nearer to the center, according to the research by NASA. Corona is the outermost part of the sun's atmosphere. The corona is usually hidden by the bright light of the sun's surface. That makes it difficult to see without using special instrument. However, the corona can be seen during the total solar eclipse. During the total solar eclipse, the moon passes between the earth and the sun. When this happens, the moon blocks out the bright light of the sun. The glowing white corona can be seen surrounding the eclipsed sun. White corona can be only seen in our naked eye when the solar eclipse occurred, because corona is dim. The corona is about 10 million times less dense than the sun's surface. This low density makes the corona much less brighter than the surface of the sun. Let's move on to the inner layer of the sun. First, the core. The core is the sun's middle region where energy is generated by thermonuclear reactions. These nuclear reactions use hydrogen to produce helium. As a result, energy is released, which leaves the sun's surface as light and heat which we receive on Earth. According to the NASA study, the core extends to roughly a quarter of the way from the sun's center. The core is the innermost or central layer of the Earth or the sun. The core is the innermost or central layer of the sun. Its temperature is around 27 million degrees Celsius. The second layer is the radiative zone. This zone is between the core and the convective zone and is roughly 70% of the sun's radius. Energy produced through nuclear fusion in the core moves steadily outwards as electromagnetic radiation, taking over 170 years to pass through the radiative zone. In this zone, energy is carried outward through radiation by photon carriers through a process where it bounces many times in a zigzag path. Lastly, the convection zone. This layer of the sun is above the radiative zone and is the outermost layer of the sun's interior. It stretches from as deep as around 200,000 km right up to the visible surface. The temperature at the bottom of the convection zone is about 2 million degrees Celsius. Energy moves toward the sun's surface through convection current of heated and cooled gas. This happens when the density of the radiative zone gets very low and the energy from the core is light form is converted to heat. The heat from the edge of the radiative zone rises until it cools down to sink back down. This pattern of heated materials rising and cooling occurs in the convection zone cell.